All right, so just start the recording again. So distance there and back, or what distance there is 3 kilometers. So there and back is 6 kilometers. Convert that to meters, I get 6,000 meters. Next question, how much time would that take? Now, since you guys know what the speed of light is, because we're really solving this problem backwards, I'm going to do distance equals speed times time. Therefore, wouldn't time be distance divided by speed? Right? And what is it? Okay, isn't that like 6,000 meters divided by 3 by 10 to the 8 meters per second? It should be a tiny, tiny, tiny amount of time. I mean, we're talking about light going back and forth here. So 6,000 divided by 3 by 10 to the 8. Looking at mine is 0.00002 seconds. You could also call that 2 times 10 to the -5 seconds if you like. Scientific notation, so pick your favorite. How far would the wheel turn? Right now, this question right here is probably the hardest question on this page. If you get past this question, you're probably good to go from here on out. How far would the wheel turn? Okay, now here's where the number of teeth matters. On my page, it says 29 teeth, which happens to match the picture actually. So let's think about the geometry of how this is working. So this wheel's going to turn just a little bit so that by the time the light does return in this tiny fraction of a second, one of these teeth will exactly cover an adjacent window. So if I have 29 teeth, shouldn't this whole wheel have to turn 1/58 of the way, right? Because if it turned 1/29 of a revolution, the tooth would go to the next tooth. That's not what I'm looking for. I'm looking for half of that. So however many teeth you have, double that because you have that many teeth and also that many windows, right? So it's like, in my case, 29 teeth and 29 windows. That's like 58 things. I only take one revolution and divide by those 58 things, right? So you get a tooth next to a window. Right. So, but instead of saying one revolution, you guys remember from December in this class, you want to do radians, which is 2 pi radians. So I'm going to take 2 pi radians, which would be one revolution, and divide that by 2 times the number of teeth. So 2n, because 2 times the number of teeth, because teeth plus windows. The 2's do cancel out. So I'm going to do pi divided by 29 teeth. And my number comes out to 0.1083 radians. Obviously, my numbers are different than your numbers, but you should be getting something that's sort of that order of magnitude. Real fast for context, times 180 over pi. That's also about 6 degrees. Okay, so this only turns about 6, my wheel only turns about 6 degrees. Hey, if you had more teeth on this wheel, I bet it wouldn't have to turn as much. Like if you had like 1,000 teeth, I bet that would be probably easier to conduct this experiment. Right? Maybe kind of one of those things to think about how does this thing work. Actually, this point in the process, you're actually one step away from getting the answer. Because look, you're looking for radians per second. How fast is it spinning? Here's how far it turns in radians. Here's how much time this process takes. Hey, could you just do this many radians divided by this many seconds? Let's try that. What is this many radians divided by this many seconds? I'm getting, so omega is equal to theta divided by t. From that point of view, I'm getting 5,000 and some radians per second. So like thousands of radians per second. Okay? Now, of course, we'll all get different answers, but you should have a similar order of magnitude. You should have like 1,000 radians per second. No, there's another approach you could have done. So let's jump through that. What is the radius of the wheel? Notice we never actually use the size of the wheel. That's a value that ends up canceling out. But let's use it anyway, utilize it, and perfect. So I have 108 centimeters diameter, 108 centimeters diameter, divide that by 2 to get the radius, but then divide that by 100 to convert from centimeters to meters. My radius is this many meters. Next question, how far would a gap move in this process? Well, if you know how far it turned and you know the radial size, that's why I was referring to that poster up there on the wall. Do you guys remember how far something turns is equal to its angular motion, angular displacement times the radial size? Here's your data right here. So take this number times this number, and what is that times that? I'm looking at 0.05848 meters. If you like, you could call that like about 5.8 centimeters, right, on my paper. for context, which is about that length right there, right? Okay, so that's how far. Okay, so take the radius that I gave you in centimeters, or sorry, I gave you a diameter in centimeters. So take that diameter in centimeters, divide by 2 because radius is half the diameter. Now that's still centimeters though. How do you go from centimeters to meters? You divide by 100. Yeah, that's how I got that number. Right. So, okay, and then take that multiply by the angular displacement, which we got before, and you'll get the linear displacement of a tooth. How far did a tooth move in meters? Finally, what's the linear speed of a tooth? Well, isn't linear speed v just distance divided by time? So here's the distance that a tooth would have moved, and here's how much time that happened. Pop those in. So take 0.05848 meters that it moved, divided by 0.00002 seconds that it happened in. I'm looking at 2924 meters per second. Okay. Crazy fast speed, but I mean, we were trying to get speed of light in this case. That makes sense. Now, the other approach you could do to get this answer, let's go ahead and confirm it. Isn't omega equal to v divided by r, right? If you go from linear to angular velocity. Here's your linear velocity, and here's the radial size. Pop those in. So what is 2924 meters per second divided by a radial size of 0.54 meters? That is a 5415 radians per second, which exactly matches the answer I got using the other methods. Yeah, so there's 2 methods to solve it on that one page. Once you guys finish that, pop that in the grade tray. I tell you guys what, if you need a few more minutes and you want to turn it in on Monday, that's all right too, but want to get off your hands and the grade tray goes into the grade book. And you guys have a good weekend.